In this video, we are going to talk about Bohr model and subshells, orbitals, and also about the electron spin. So, let's break down what Niels Bohr discovered. In an atom, electrons don't just float anywhere. They orbit around the nucleus at a specific fixed distance. Bohr named these circular paths as orbits or energy levels. So look here, E1, E2, E3 and also E4. So Bohr named these circular paths as the orbits or energy levels. And electron can sit on E1 or jump to E2, but it can never stop in between two energy levels. So think it just like climbing a ladder. You can stand on step 1 or step 2, but you can't stand in middle layer between that two step. Here is the same thing. Electrons can't sit on between the E1 and E2. And let's move to the next slide. Energy levels. It represents the simple N. Here, each energy level is further away from the nucleus. So, what does this mean? Notice how E1 is close to the nucleus and E2, E3, E4 and E5 is close to the nucleus. Here, as the principal quantum number n is increases, then each energy level get further and further away from the nucleus. You can see E1 has this distance, E2 has more distance than the E1 and here is the same. Remember, the nucleus in the center is positively charged and the electrons in orbit are negatively charged. So opposite charge, what happens? They are going to attract. Because of this strong attraction, electrons naturally wants to be as close to the nucleus as possible. That is why electrons will always fill the lowest energy level first before the filling any other higher levels. Okay, let's move to the subshells. Think of main energy levels represented as we know simple N as floors in a building and subshells as the rooms in each floor. As energy level is increased, the space around the nucleus get larger. So we need more subshells to cover that space. You can see the first energy level called as n equal to 1. It has one subshell. Subshell is S. The second energy level has two subshells called S and P. And the third energy level has three subshells called S, P and D. Fourth energy level has four subshells called S, P, D and F. So here there are these are the 3D view form of the subshells S, P, D and F. Here also S has one orbit, P has three orbits called as X, Y, Z. We know X, Y, Z is a 3D view form. So D has 5 orbits, F has 7 orbitals. Here also there is one S orbits. There are 3 P orbits called X, Y and P, Z. There are 5 orbits here and also there are 7 orbitals here. Then, now let's talk about how electrons behave inside the single orbital. It is called as electron spin. Every electron behaves like a tiny magnet. We know every electron behaves like a magnet spinning on its own axis. It can spin in only two directions. We can call as spin up and spin down. So, what is the Pauli exclusion principle? It states that no two electrons in the same orbital can have the exact same spin. You can see here, this is positive and this is negative. Now let's connect with we learned into this summary table. This shows the maximum electron capacity for each subcells and main energy levels. Let's understand this summary table. So remember the core rule, one orbital is equal to can have two maximum electrons. So we need to know that for the fill this table. Here we know here we look at the subshell capacity. It has one orbital, so it multiply by two maximum electrons, then it get as here has two electrons, and look here has 6 electrons, in here has 10 electrons, here has 15 electrons. So we know principal shell capacity. We can then find one and a first orbital has two. So I hope you already know what is the model, subshells, orbitals, and also electron spin. So this is the end of this video. So thank you for listening.